have just a number by itself. You have to show the reader how you got that answer. The words are you have to convince the reader. Guys, I like the way the chief reader said that. You convince us. So we are not allowed to assume. And so if we just see the answer there, I don't know how you got negative 0.1. Could have been just lucky guess. Could have seen it from your neighbor because, you know, sometimes you're pretty close together. So you have to show your work. And look at that. 1 point for the answer, 1 for the units. I would always put the units in because even if they don't ask for units and you put them in, there's no penalty, even if you do it wrong. So what you tend to do is forget the units. Did anybody, I want to ask, did everybody remember to put the units in? Yeah. So read the question twice, at least twice. So it asks for the units, and you could use miles per minute. That's the velocity units, and the acceleration will be over the time again. This will also be an acceptable answer. So questions? You can write it this way or per minute squared. Safer to write it this way. But that is, acceleration is distance per minute squared, per time squared. Okay, C. What happens on C? Now, in the last class, period 2, I said, if you have problems with this, change this into just a line graph. Because what's true about my velocity? And by the way, I forgot to mention that the mistake that was made this year on this exam was students just reading the slope off their graph like that and said it's -1. They didn't put the decimals in. So make sure you read your scales correctly. Okay, so we start at 0. Now, some people get confused, the fact that I have a maximum value there. I don't really care about that. All I care about is you're going one direction if the velocity is positive, you're going a different direction if the velocity is negative. So where does she stop? At 2. Where's the next 0? At 4. And it stays 0 between 4 and 5. I'm going to do this, like that. That's a 0. And then it doesn't change sign again until 12. So when you're looking at your graph, I like to put the zeros in there. And by the way, when you're walking, this doesn't even make sense to have an abrupt change like that on that derivative, but whatever. So what's true about my derivative in between 1 and 2? Positive or negative? It's positive. And then between 2 and 4, it's negative. And then this is 0 here. So what's happening? She stopped, right? She's still at home. Probably doing what? Finding her assignment, right? Well, she went home to get her calculus assignment, right? And this is what? Positive or negative? So if I wanted to look at the position curve, I could, without looking at that, because the shape of that really doesn't affect this that much. My function's increasing. She stops, then it's decreasing, and then she stops for a while, and then it's increasing, and she stops again when she gets to where? Where's she going? School. She stops again when she gets to school. And we can calculate the distance. Well, we're going to save that. You can go ahead and read ahead and do a little bit of D, not the whole thing. So she stops at 2 minutes, and how do I know that she returns home? Right. So you say the velocity goes from positive to negative or changes sign. Some of you want to say the velocity is 0. Now, I'll make this a positive number. Okay, that's positive. So I'm walking over here, and I stop. My velocity is 0, and I continue walking this way. Have I turned around? No. The only way for turn around is what has to happen to the sign. Right, if I walk this way, I'm positive. This is a vector. So when I walk backwards now, back to home, it's negative. So you have to make sure you say that. Saying velocity 0 will not get you the answer point. And so that is right here. 1 point for the answer, you'll get the answer point, but you won't get the point for the reason. And it changes from positive to negative. Question? Yeah. It's the change, not just the less than. It has to change from positive to negative or negative to positive. It could have said velocity changes sign. Could have done that. I would be safer saying positive to negative. I think. Unless you want negative to positive, in which case you'd be wrong. Okay? That's 4 points. That's not too bad of a problem, right? And actually, if you look at D, you can't do B because we really haven't talked about it. It says we want to know who went further. And remember, what does the distance under the curve, what does the area under the curve represent? The distance. So you can find how far she is from school, not by writing the equations, but by using what? Geometry. Geometry. So you could do that. We will come back and hit on that again. But I'm going to hand out the next one. This next worksheet is from the University of Minnesota when I taught there back in 97, 98. And there's some interesting discussions on this problem. You will need your graphing calculator. If you don't have one, I do have Inspire calculators over there, but then you have to figure out how to use them. So I see a number of people are picking up the Inspires, which is wonderful. I may have to bring up 2 calculators to do this problem.
You want us to try to do it?
Yeah, go ahead and try it. You're going to need your graphing calculator. This is her. There's not as much on the exam as there used to be with the graphing calculator. Mostly problems 1 and 2, like this problem that we just did, you will need a graphing calculator on that one. There you go. Everybody got one? Oh, yeah, I got one. Everybody have a yellow sheet, gold sheet, whatever. So get your graphing calculator. I have 84s, but I have Inspires. And those of you who don't know how to do an Inspire, we'll start there. Pardon? What? Do you know how to use the stats on that? Because that's really awesome, the stats part. Oh, yeah. You just tap on it and it puts your stats on the axes for you. Do you remember where absolute value is? I'm going to bring up both. Now what's nice about the Inspire is I just have to type in ABS. You can just type, it's like a Windows machine where you just type things, where in the old Macintoshes, the old Apples, you had drop-down menus, and you couldn't just type things in. You had to go to the menu. Well, that's what this one does. So y equals, I'm going to clear, and it was 0.5, right? And where's absolute value? Math. Oh, I don't want that. I want the screen. And I have to go over to NUM for the numbers, and this does a whole bunch of different things, but absolute value is 1. And I have the new operating system, so mine looks a little different. If you have an 84, any 84, and you don't have the new operating system, I can help you with that. And we're going to raise that to the 3/2 power. So I'm going to use this caret. And I'm not going to use 3/2, I'm going to use 1.5. Because I'm lazy. Plus 2. And they give you the domain is between 0 and 2. Now, Mrs. Hirschman does a zoom fit, and I don't like to do a zoom fit. Well, let's do a zoom fit, and I'll show you why. It works if you're given the domain, but it doesn't work every time. I wish it did, but it doesn't. Zoom stat if you're in stats, by the way. Zoom fit. It's thinking. Mm-hmm. Yeah, we have to learn how to do that. Yeah, we're not even close. That looks like it almost touches the axis, but in reality it doesn't. If you look at your window, it's 2.0 to 2.9. I'm going to make this minimum value to be -1. Then I can have a more accurate picture of my graph. It won't be as curvy, though.
What's your y value?
2. No, 2.9. Make it 3. Looks like 3. And there it is. Now I got to figure out how to get back to my smart board. Okay. Oh. And now I gotta. This is easier. There it is. On the exam, they'll tell you if they want midpoint or if they want right Riemann sum, left, and it's called a Riemann sum, right ram and left ram. Okay, now I can do this. Okay, if I go to the Inspire calculator, I want to have a new document. I never save anything, and I want to graph. And I want to do 1/2, so it's 0.5, and I can just type in absolute value, A, B, S. It's shown here someplace, I don't know where. And then it was X minus, I thought it was 1.5, 0.5, parentheses. It tells you, hey, we think you need a parentheses there, and I'm going to raise that to the 1.5. So it's like my new operating system, and it's +2. You really want the new operating system. It does fractions and stuff. And I just press enter. I worry about the window later. And I want my window to be starting at 0 and going to 2. But something that's interesting about this, with your mouse and cursor, you can just grab your axes and do things like that. I can translate it. I'll be that way. Problem is always, for me, it's always grabbing the right thing. But I'd rather go, it's easier for me just to go into my window. And your window is Window Zoom. Those of you who have this. And we're just the window settings. Press enter. And I want that to be 0. And I can show you how to also get more decimal places. And my max is going to be 2. I always auto on that. And then Y minimum, I'll make that -1. So it's the same as the other one. And we'll make this 3. Whoops. You're right. Clear. This is the Inspire. And once you see how nice it is, oh, it's much nicer to look at. And then this is going to be 3.
Can you still do a block?
Games are now coming out of it. There. Nice little picture here. And I don't like this label here, so I'm going to move it.
Oh, yeah.
There. So sometimes the pictures are nicer, and you get color besides. But finding an intersection point, if I wanted to do y equals x, so I'm going to type in x here, because that's what's really awesome, and finding zeros too. That's, let's make it 2x. I want to show you something clear. Oh, but they're so nice. 2x, I'll graph that one. I want to find that intersection point, so I go on here to menu, and I analyze my graph, and I want to find the intersection. It's much easier. You just use your mouse, and you move it. Whoops. I don't want to do that. Come on, line move. Oh, it makes me do it on the computer. I can't seem to do it on my smartboard for some reason. It works fine on the calculator. And inflection. Oh, it has inflection points. That would be kind of nice. You don't have that. And you click there, and you click there, and it gives you the intersection point. Kind of cool. So, but if anybody's working with those, I have to make sure you know how to use it. No, they do have a mouse, though. The touchscreen is in the works. The reason why we don't have touchscreen is because it's not allowed on the SATs and ACTs and the AP exam. The reason. This one is. The regular Inspire is. The CAS does all the calculus. It's allowed everywhere but the ACT and IB exams. CAS is the one that will do your derivatives for you. If you want to find the derivative of the sine function, it'll give it to you. Which is very cool. But you can also get apps on your iPhones that do CAS. Yes. Well, Wolfram Alpha does it, but I don't know. You just have to go and search.
Search like a CAS company. Wolfram Alpha. Is that Wolfram Alpha?
Or you can ask Siri. Oh, you don't have Siri. Okay. Are we ready to divide this up? Did you guys draw this? Do we have any answers? What the heck is going on here? Okay, I'll do it this way then. I was going to make it pretty. And we're dividing this into 4 equal parts. You know what? You don't have to divide it in equal parts, but it told us to, didn't it? And this is where? 1, and this is 2. This is a half, or 0.5, because we're going to use calculators. Now, I want the midpoint. Sorry, you're right. I know, this is good. Right. Okay, guys, did you graph it yet? Did you draw it? So draw in your midpoints. Now, you're going to find the height of your rectangle by evaluating the function at the midpoint. And what's going to happen to my rectangle? Some will be under and some will be over. And same thing here. Some will be under and some will be over. And my midpoint, by the way, where's the midpoint here? 0.25. And if you do an LRAM, you would evaluate the function at 0. If you were to do an RRAM, you'd evaluate the function at 0.5. You get different answers. Don't forget, Mrs. Hersman and I are here, and Mr. Dunn are here in the morning, tomorrow morning, if you need extra help on this section. So your homework is to finish up 5-1 if you haven't. And this one looks pretty close. And that one is, where's this one going to be? Is that 0.75? Then this is at 1.25. And this is at 1.75. Now I just want to find the areas of those rectangles. So if you were on the AP exam, you would have to at least write out your plans. What's wrong with my... Oh, you guys doing it? Who's got my... This works. Why is this not working? Yeah, that's weird. Okay. So the area is equal to... Well, what's the width of each interval? It's a half. Is that the same for all these? Can we just factor it out then? Sure. I don't want to do all that work. So now to find the area of this rectangle, I'll find the base is a half and the height is the value of the function at 0.25 plus. And then what am I going to do? Base is a half times this height, which is f of what? 0.75. This is sufficient to get your point on the exam. You don't have to give them all the numbers. You don't want to give them all the numbers because they're not nice. The area, yeah. This is. If you give the numbers, you have to give all the decimal places. That's a lot. So it'd be easier to do this. And then this is what? You have to use all the decimal places. You wouldn't have to give them all, but you have to use them. And I'll show you how I can do this in one entry on your calculator. Plus, and then it's f of what? 1.75. Are we okay with that part? And then how do I use my calculator? An easy way. There's a couple ways. You can go into your table, and you can get a table on the Inspire by doing a Control-T, and then you'll see a table. I don't like the tables on those calculators as much as this one. So I can go to the table, and my first value is 0.5 that I'm going to evaluate. And I'm going to increase by, what are they increasing by? 0.5, right? Oh, sorry, it's 0.25, you're right. 0.25, they're increasing by 0.5. And then I can go second table. And there they are, except that that's not all the decimal places. If I arrow to the right, I get all the decimal places. So in your calculations, if you don't use all those places, you may not come up with the answer that the readers have. And it has to match to the first 3. Okay, so that's one way to do it, and you could put these numbers in, and this will probably work, but then how am I going to put in my calculator so I have all those places? That seems hard. So there's another way to do it, which may seem hard too. I want to do a half times and I want to evaluate my function at all those places. Well, so what's my function? It's in y1. How many of you have the new operating system? A couple of you? You're going to go alpha and then trace, and then it allows you to pick up y1 easily. If you have an 84, 83 can't help you, but 84, I can upgrade your operating system so you can do this. Not the 83, sorry. Yeah, any 84. And I want to evaluate y1 at 0.25 plus. Now, for the rest of us who don't have that, we need to know how to find y1. I go under vars, and for me, I've done this for so long, it's actually almost easier to go this route. We want to go to y variables. You're not going to use any of that other stuff there, and it's always going to be a function in this class. Next year in BC, you'll learn the other ones. If you go to Calc 2, you'll learn the other ones. It depends on what you're studying. Yeah, in Calc 2 in college. And this is what? What's the next one? 0.75? Plus. And then I want to get y1. Since most of us are in this one, we'll do this one. And if I go too fast, you have to let me know. That's y1. You should eventually get to be very fast with this. What's this, Adam? What's this, 1.25? Plus, and then I want to get vars. You can write all those numbers down. I'm not willing to do it because you don't have to. As long as you tell them the plan, I clearly understand this is what you want to do. And then all we do is look for the number at the end. So we don't really care about seeing the numbers in between. Close my parentheses, enter. How'd you get 4.58? Did you guys get that? Okay. Thought we had 4.58 in the other class. Yeah, I thought, well, it's not bad though. Let's do the exact answer. Might as well since we're here. So here's my graph. Remember how to do this? You go second, calculate, and you want to find that little curve. That's S for sum, okay, Cole? So it's 7. And my lower limit is 0. And my upper limit is 2. Oh, there we go. And it'll shade. And I have programs for you that you can divide this up and use midpoint rule, and you can actually see that picture. All you need is an 83 or better. And you want my programs. I have some freak stuff on there. All the freak stuff you could ever want is on there. And all the calculus formulas are in there. But you can't use the calculator that much on the exam. Plus, if you're using your calculator, you're going to run out of time. Okay? That's the real answer. 4.58. We have 4.57. I don't think that's bad. You think? Now, when I look at this picture, I can't really guarantee that that answer is going to be less than the actual area. So on part B, it says, you have to read the words carefully. Now find the area under the curve between 0 and 2, choosing sample points to ensure that you have an underestimate. And you have to absolutely be positive it will be under. Yeah. 3. I would write them all because we don't look beyond the 3. These could be all wrong. We don't care. We only look at the first 3. And you can round down or up. It doesn't. Now this one would be 4.574 because the 2 will not make it round. But had it been a 5 or 6 or something, you could have given me the 4, or you could make it rounded up to the 5. Okay, so I'll give you a chance to see how you would draw B. I got to get another picture here anyway. I want to be absolutely positive. I'm going to bet my life on it that this is an underestimate. There can be no questions about, could this really be an underestimate or might I be over? So try it. You need to draw the picture. I'm going to get another picture, take another picture here. And I have to clear my draw, though. I don't want that. Right. Or could you use a combination?
What if we did? What if we just
You have to insure it.
I didn't do it. I wanted to do LRAN somehow.
I have to be absolutely 100% positive. When you do one of the RAMs, one does come to be over.
So cool. So you can't match the RAM.
Yes. It says to do 4 equal intervals on this one, but no. I want to make sure. I want to guarantee. Can you mix and match? Oh, now this is working. Weird. Okay. They do say 4 equal intervals. And I want an absolute guarantee. So I will take the right one. Okay?
Yep.
I'll take that right one. I want to guarantee it. Looks like I'll take this right one, right? But I want to guarantee it. And I don't want to use the right one here because if I do the right one here, there is some that is above. And you're probably going to say, well, I can see that that obviously is going to be still less. That may be true, may not be true. You have to guarantee it. It's all in that word, ensure. And there were a lot of discussions about that problem at the university because they did not get the points unless they absolutely were positive it's an underestimate. And if I use the left RAM on that one, I will get an underestimate. Does guarantee. You'd have to actually prove it. No, you had to do it this way. And the point of it is it doesn't matter how you do the rectangles. You could have all different sizes. I could put one in here like this, and then I could have another one. I might choose this to be my sample point and use that for my height. They can be all different sizes. They can have all different sample points. That was what the university was trying to get across. And the name of this, when we do this, is called a Riemann sum. Because they're going to use that word on the exam.
Oh, it's back there, isn't it?
I don't know. Okay. And I just tell the students, that's the name of the German mathematician, Riemann. So if you don't like Riemann sum, he's just asking to find the area under the curve. That's all it is. No, he's German. And I just say, if Riemann scares you, call it a Golombesky sum. Because I know my kids would come in and say, oh, they wanted a Riemann sum. It's just asking the area under the curve. Well, we also divide this up into an infinite number of rectangles and took a limit. What? Because then that's not so scary as Riemann. It's just a little way to reduce your anxiety when you're on the exam. You see, Riemann, just saying find the area under the curves. They're just giving the acknowledgement to him that he actually invented that. So, do we have any answers? 4.57. I'm sorry, I can't hear you. I don't know if we got a guarantee there. It's going to be 1/2 times f of, now I'm going to do the right side. So here's 1, here's 2, so here's 1/2, and here's 1.5. So it's f of 0.5. Oh, I'll show you something. Plus f of 1 plus f of 1.5 plus f of 2. And on the Inspire, you guys can do, by the way, on the Inspire, you would just type in 1. Oh, sorry. You're right, because I was blindly thinking of something else. I have to have 1.5 twice, don't I? On the Inspire, you can actually type in, it'll be an F1, you do F1 in parentheses 0.5. Now, also on the Inspire, you can go back up and do what I'm going to do on the 84. Okay, you guys? You can go back up if you have the new operating system and press enter. And then all you have to do is go in and change the numbers. Who wants to retype all that? Or, if you don't have the new operating system, you still can do that. You just arrow up on your Inspire. Yes. Second entry on the 84, we'll get that. And now this says, that little arrow says there's more there, so I'll go to the beginning. And we're going to put in 0.5, right? It's faster for you guys. This board is slow. Okay, I just want 0.5, so I can just delete the 2. And then I want 1. I'm going to delete. Still 4. No. Not close yet. Okay, plus. What's the next one? 1.5, right? 1.5, and I'll have to go and delete that other 5. And then I could have doubled it, but I'm just going to put in 1.5 here again. Well, at least C4. I wish it would wrap around, but it doesn't. 5, and I'll have to delete that other 5. Whoops. Delete. That's something you might want to do if you have to do repeated calculations. I'll do the same thing. So there's the answer, 1.338. Pardon?
You use 0.5 or 1.5 and what?
Right here. 0.51, 1.5, and 1.5. Okay? Did you guys get 4.338?
Yeah, that's exactly what I got.
The real one, you're right, is 4. But remember, we wanted to guarantee this was an underestimate, which it clearly is. Did you have, is this, now, you would get a point for this line that I have right here and a point for the answer there. Don't cheat. Because when the question is, why do I use 1.5 twice? It's because when I'm looking at this rectangle, it's going to be an LRAM. So I'm going to find the height of the rectangle using the left side of the rectangle rather than the right. If I do the right, I'm going to be above. Sorry, I've got a funny thing on my board. That'll be an over, and I want to guarantee it's an under. So it all turned out to be semantics on this. You had to know what that meant. Okay, those were our activities. Are there questions on homework? The quick review on 5.2, skip, cross it out. So we're not doing it.
We just do day 1 and day 2.
The quick review for 5.1 and the regular assignment for 5.1, the yellow worksheet. And that's it. I mean, if you've done it all, you're done. But you may have some questions. Is everybody finding the answers online okay?
I used to have it, but then my brother stole my calculator.
Well, that wasn't very nice. Well, let's let me do it. Let me see. Oh, this doesn't have it. Never mind. It'll take a while.
So 1.5 in the book, and 9, 11, 12,
Okay, you guys, you have homework? Oh, no, I forgot to receive first. That's going to mess up. Yeah. You always have to receive first. Now, do you have any programs on here?
Not that I care about.
Okay. I forgot about that. You got to change your batteries. And then archive your programs. Then you won't lose anything that's there. Okay, you guys, did you know how to do 17?
What?
Number 17. Adam, would you like to come up and do 17 for us?
17. Okay, so I'm walking along the bank of a tidal river. Watching the incoming tide. Okay. About how far up the street is it? Well, this is going to be a little fine.
No, you don't even have to draw a picture unless you want
Can I
to.
grab it?
You may, but you don't have to.
I'm going to do it. It's going to take a while, though. a lot of numbers.
Well, it's not that bad.
Okay, good. Alright, so... Wait, which ones do you want me to do? LRAM and RRAM?
It wants you to do, I don't know.
I'll do the LRAM one first.
How wide are the bases on this problem?
5.
5. So they're all the same, but factor it out. Yep.
What?
What? Oh, is it?
Oh my god.
That's okay.
That's... Oh, okay, yeah, that'll work. Yeah.
And how many of these numbers are you going to add together? They would never ask you to do this much. Most I've ever seen, I think, on the exam is 5 rectangles. So you're going to add up all the velocities. Yeah. And what's your last velocity? No. LRAM.
Oh.
1.2. What was coming? I can show you some stuff that's not real stuff. I actually have an email. Yeah. Okay, I don't know what the answer is, but you get the point for the setup. By the way, guys, Julian, you guys, you get a point for just writing that, and if you're in the middle exam, you don't have to add it. Just leave it. You add it wrong, you lose the point. This is what they want to see. They want to see this part right here. Somebody wanted to do that. Right, Ram? No, just for setting it up. You'll have to go and look at the scoring rubric. Yeah, don't simplify it. It's the velocity. So this is the left side of my rectangle. So how would you do the right one then?
You'd skip this one and add all of these.
All these up and include that one. Good job. Are we okay with that problem? We did it kind of quickly. Are you okay with it?
You get yours first.
Oh, and then you have to multiply because you're in 5 minutes and we want it in seconds. So 1 minute equals how many seconds? 60. So you're going to multiply it by.
Like that?
Already?
I like to skip half of it.
Well, we're not out of here yet.
Oh, we gotta be getting.
Now, how about that one? Did you guys get stuck on that one?
I don't get stuck on anything.
31.41593. Okay, you guys, how do you do this one? What's the volume of a cylinder? You're going to take all these little cylinders and add them up. It won't be exact, but it'll be close. So the area of the base is pi r squared times the height. The height is this. How big is the height of each of these little cylinders? 1, right? And this is the radius. Okay, guys, Natalie, what's the radius? Isn't the radius equal to my function?
Yes, it is.
The radius is the y-coordinate here. What's y equal to? Square root of x. So to find the volume for one of the cylinders, it's pi times the square root of x squared, and the thickness of the cylinder is 1. So for each one, it's going to be pi x times 1. And it's easy after that. Because what's the first radius? V1 is equal to pi times 1 times 1. What's the next one? Pi times, what's this radius? 2. Well, it's the square root of 2, but it's squared. So if you want to do that, we can. Times 1. Okay, can you do all 5 of them then? Yeah, so it's not that bad. Also, when you do these, please do the standardized test questions. Because those are the ones that are going to help prepare you for the exam. This one is, I want the area enclosed between that graph. Well, you should have an idea that it looks like this. Now, this would be in the graphing calculator section of the exam, so you could graph it. And I want to divide that into 4 rectangles. I can't do it in my head. I have to write it out. And which one do we want? Oh, midpoints. So you're going to find the midpoint for each one of these. So my height's the midpoint. Are you understanding the midpoint one? That's probably the most important one of them all. So I find the midpoint in my interval. I find f at that point, and then I find the height. So sums out, sums in. Midpoint's generally the best approximation. Is that okay? And these, of course, are going to be hard. Yeah, not really. Don't forget I'm here in the morning. And you add them up. You follow Adam. You add them up. Add them. Add them up. Sorry, sometimes I get a little goofy.